In this video, I'm going to finish off the transformation rules being applied to the trig functions. We're doing the translations in this one. So that is the shifts, both horizontal shifts and vertical shifts. Just moving up, down, left, right. In fact, I claim they're so easy, I'm just going to go jump straight into one function that has both transformations and do them at the same time. Before I get started, remember, f is any function you can think of. Right now I'm focusing in on the trig functions because I'm in pre-calculus. But these apply to the square root function, a logarithm function, any function. And I'm focusing in on the d and the c. So at the end of your function, if you have sine of x plus 2, all that's going to do is take every single point and shift them vertically up 2 units. If d is 2, you go up 2. Now if you're subtracting 3, then you go down 3. That makes sense. So that plus d at the end is just how far do you need to go up or down. So if it's plus 3 halves, then you'll go every single point. You just add 3 halves to that y value. Oh yeah, again, d is outside of the argument of this trig function. Anything on the outside, those transformations affect the y values. So a plus d, you're just moving them up, you're moving them down. The x value associated with it is not changing. Now the c, it will be affecting the x value. C is inside the argument, so that's affecting the x values. So that's moving them left, right, horizontally. Now remember from the dilations, anything on the inside, it kind of goes the opposite of what you want it to. So because of the minus sign, when I first see that, I think, oh, that should go left in the negative region. But no, it actually ends up going right. To see that, just go through the motions of graphing a few of these and plotting points, and you'll figure out, oh yeah, when I plug in this value, it does end up over there. So, but I know I'm just applying the rules here. The rule says if you have a c that follows a minus sign, you need to go in the right direction. If you have a c that follows a plus sign, you need to go in the negative or the left direction. So I've been given the task of graphing cosine of x plus pi fourths plus 1. First, I'm going to identify my transformations. I have a c value of a negative pi fourths. If the negative confuses you, I just want it to follow this formula. I want to see the c minus a negative. So now I have a negative pi fourths. If that confuses you, don't worry. Just identify it as pi fourths and know that because I have a plus sign, then I should be moving left that distance. So I should be moving left pi fourths. Now I also have a d. My d is a positive 1, so I know that I'm going to be going up 1 unit. And you can handle this a couple different ways. You could start with a parent, do one translation, and then the next. And in the next video, I think we'll talk about order, but here it wouldn't matter if I go left then up or up then left. It'll be the same. I think though, I'll just try to do this in one fell swoop. I'll try to do it at the same time. So I know I'm going to be going left and up. So as I draw my axes, I need room to go up. So normally I would kind of cap out at 1 because that's cosine, the highest value is 1. But that going up 1, well, that's going to go all the way up to 2 now. So I just need to represent that on my y-axis. Left pi fourths. Well, if I don't want to put my axes right here because I'm going to need to go left. So let's maybe, I don't know, give room to go left. I think I will put my axes kind of dead smack in the middle. I'll graph cosine from negative pi to positive pi to show the full period of 2 pi. And then I'll decide to shift left and up. All right, I need a y-axis. If I let this be 2, 4, I'll let every 4 squares be 1. And there should be my horizontal axis. I know if I count by pi twelfths, then I need 12 squares to count as 1 pi. But I'm going to go a little bit further than that. All right, just do my normal skip dash 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 skip dash. That's negative pi halves. Skip dash 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 skip dash. That's negative pi. And I'm going to need to go another pi fourths. How many squares is pi fourths? Well, if I were to label this, every 3 squares, or every 3 pi twelfths, is 1 pi fourths. So I need to go at least 3 more squares to the left. So I'll just kind of continue with my motion. Skip, dash, 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 skip, dash. All right, I'll label that in a second. I'm going to go out to pi this direction. Skip, dash, 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 skip, dash, that's pi halves. Skip, dash, 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 skip, dash, that's pi. If I'm going to graph cosine, the thirds are real nice. I for sure want those. I think I will just start with a black parent graph of just regular cosine, just to help me, I don't know, visualize what's about to happen. So I'll graph cosine, maybe a dotted line to help me have less graphs on here. I know cosine of 0 is 1. It starts high. Pi halves, it's 0. Neg pi halves, it's 0. Pi and neg pi is neg 1. The thirds are real nice. They're those half values. And I'm just going to graph a dotted line of my parent graph cosine. Now, I need to translate this graph, left and up. Really easy. I'll start with a point straight in center, 0, 1. I need to go left pi fourths, which is 3 squares on my graph. If you labeled your x-axis differently, then it may be different. But if you counted by pi twelfths like I did, then it should be 3 squares and then up 1. So I'm doing them at the same time. Maybe I should do like just a dot there and a dot there. All right, the halves. I'm going to do these at the same time. They need to go left 3 squares and then up 4. Left 3 squares, up 4. Now, I just labeled 2 new points. I can clearly read the y value being at 3 halves, but I can no longer read those x values, and that's very important to me. I know it was at 3 halves, comma half. I'd like to know what is the x value. So what is this x value? Well, this is convenient because it's just going to be a pi 12th. In fact, it is a 1 pi 12th. I could do some subtraction if I needed to. Hopefully not. Hopefully the visual clues are more powerful. But if I had pi thirds and I knew I needed to move left pi fourths, well, that's just going in the negative region or subtracting pi fourths. In order to subtract these two, I would need a common denominator. So I'm going to convert them to twelfths, which is what I've said. Count by twelfths. Everything's easy. So this is 4 pi twelfths minus 3 pi twelfths, which, yes, is 1 pi 12th. So if you ever get kind of like lost on your axes, maybe they're not so pretty, maybe you're subtracting pi ninths, that's kind of nasty, then yeah, you may need to go off to the side and figure out what's going on. But I think for the translation homework, I've kept these pretty. They should all be nice and pretty. Okay, this one here, this green one, I should be able to just count this out. Neg 1, neg 2, neg 3, neg 4, neg 5, neg 6, neg 7 pi twelfths. Okay, I'm going to continue with my zeros. They're at negative pi halves and pi halves. I'm just going to go left pi fourths and up 1. So the y value is now 1. And again, I need to label my axes. They probably should have been labeled beforehand. This is going to be a pi fourths. This will be a negative 3 pi fourths. I'm halfway done because I have shown here 1/2 of the graph, or 1 pi distance, and I know that the cosine period should be 2 pi. There was no b to affect the period, so the period is still 2 pi, and I've only shown a distance of 1 pi. I'm not done yet. From that 0 position, I need to show that negativity. I need to show this curve outward and down. Just continuing. I had pretty points at the 2 pi thirds and negative 2 pi thirds. I will continue to move them left pi fourths, up 1, label the axes. This one's going to be 5 pi 6. I'm just going to count this one, neg 7, neg 8, neg 9, neg 10, neg 11 pi twelfths. Yes, that makes sense. One more pi 12th and I would be at negative pi, negative 12 pi twelfths. Lastly, my pretty points at pi, neg pi, comma, neg 1. Shift those over. Those will now be my x-intercepts. Make sure those points are labeled on my x-axis. The right one's easy. It should have been labeled to begin with. That is 3 pi fourths. This one, if I just count, skip 6, it's the next fourth. So neg 3, neg 4, neg 5 pi fourths. And this has that curvature, like if this curve is concave down, what I'm about to graph is concave up. Oops, there we go. So all I did is I took my parent graph and I simply applied the translations, which are shifts. In this case, I had one going left a distance and up a distance. And I was able to do them at the same time. You could do one at a time. Just make sure you label your graph. In fact, I need to label this graph. My green graph is cosine of x plus pi fourths plus 1. While I have this graph visualized here, let me see if I can answer those questions that Mr. Simpson always likes to ask. Like, what is the domain? Well, this graph is going to continue this cosine wave forever. So the domain is still not restricted in any way. So you could say from negative infinity to positive infinity, or just shortcut all real numbers. Range. Normally, cosine is bound between negative 1 and positive 1. But because we shifted everything up 1, I'm now bound between 0 as my lower range value and 2 as my upper. 0 to 2. X-intercepts. All right, I'm going to go off and list a good one. So 3 pi fourths. And then I'm going to add the distance to the next x intercept. And this looks like it's going to hit the x every, what's the distance? 2 pi. Every 2 pi, I will go and hit the x-axis again. So I'm going to say plus 2 pi k comma 0. This x-intercept is in intercept form. I've got an x value and a y value. If k is 0, then I have the coordinate 3 pi fourths comma 0. If k is -1, then I'm subtracting 2 pi, and I have that right here. 3 pi fourths minus 2 pi will give me a -5 pi fourths. Ooh, now the y-intercept, that may be a little bit more challenging. And I probably don't want to ask that question just yet. Let's see. 2, 3, 1, 2, 3. Oh, I should know that value. Yeah. Okay, so if I'm looking for the y-intercept, the way we're supposed to do it is set the x to 0 and solve. But I'm in this idea of I want to do everything using these transformations. So knowing that this is my high point on the green graph and that my y-intercept is 3 squares away, or pi fourths distance. So if I were to start at the origin, 3 squares is pi fourths. So what is that value right there? What is cosine of pi fourths? Because when I shift it left pi fourths, I'll hit the y-axis, and then I'll need to add 1 to it to find that y value. Let me walk through that again. Cosine of pi fourths is the square root of 2 over 2. I'm taking that y value, I'm moving it here, so the y value didn't change until I added 1 to it. So I'm just going to take that root 2 over 2 and add 1. Well, I'm looking at the value, maybe you get a common denominator, call that 2 over 2. So this y value here is 2 plus root 2 all over 2. Or you could just call that 1 plus root 2 over 2. So I claim the y-intercept is an x value of 0 and a y value of 2 plus root 2 over 2. Again, the way I got that. I didn't do any sort of calculations. I didn't do any sort of solving. I did it based off the graph itself. I know on normal cosine, that high point is 3 squares, or in this case pi fourths away from this point here, which is pi fourths comma root 2 over 2. When I shifted that point, it hit the y-axis and then went up 1. So all I need to do is take that y value and add 1 to it. So I do that. Root 2 over 2 plus 1. Try to make it pretty. That's 2 root 2 all over 2. Period. Unchanged. It still takes me a distance of 2 pi to repeat myself. Amplitude. Unchanged. The transformation that affects the amplitude is the A. I don't have an A. The amplitude is not changed. The transformation that affects the period is the B. I don't have a B. The period is unchanged. So the amplitude is still going to be 1. From that 0 position, this wave still has a height of 1. Or another way to think about amplitude is the high value minus the low value. 2 minus 0 is 2. the absolute value of that, and then half it, 1. All right. I claim you are good on translations. I think you can handle the homework. Take it one step at a time until you're comfortable. The hardest part is labeling the axes. In fact, if I had labeled my axes from the get-go, it would have made the shifting a little bit easier. So on these translations, label your axes. And I think you got this. See you in the next video.